Okay, the next topic would be classifying lines as parallel, perpendicular, or neither by comparing the slopes of line. So let's try to look at example number 7. So we can see that the two lines here are on a coordinate plane and they are intersecting lines. So it is very difficult for us, or it is going to be difficult if we assume that the lines are perpendicular or parallel by just merely looking at the picture. So what we have to do is to still have to solve for the slope. Okay, so again, I'm going to write here, slope is equal to rise over run, or change in y over change in x, x1, y1. Okay, now for this, the first thing you have to do is to identify the coordinates of points like this line. We have here line AB, and the coordinates of A would be 1, 2, 3, 4, 5. So when you are writing the coordinates, you are going to always look at the x-axis first. So the x-axis would be -5, and the y would be 1, 2, 3, and 4. So 4 for the y. So this is your x1, this would be your y1. For the b coordinates, we have here 1, 2, 3, 4. So your x is 4, and then your y would be 1. Okay, so we have here x2, y2. Now we are able to get the slope of line AB by following the formula. So y2 here is 1 minus y1 is 4 over x2 is 4 minus x1 is -5. And this would be equal to -3 over, so as you can see here, this is two negatives right here. So negative times negatives becomes positive. So we have 4 plus 5 is equal to 9. Now this requires, we need to simplify that. Okay, so -3 over 9. So we have to divide both side by both the numerator and the denominator by 3. So -3 divided by 3 is -1 over 9 divided 3 is 3. So the slope of line AB is -1/3. Now let us try to look at the line CD. So let me just erase what I have marked there first, so you'll not get confused. So for line CD, so this is line CD right here. So I'm going to find the coordinate of C. So C is somewhere here, so we will have 1 and 2, -2 for the x because it's going to the left, and then 1, 2, 3, 3 to the y. So this is x1, y1, and your D coordinates would be, this is 1, 2, 3, 4. So your x is -4 and 1, 2, 3. And we have D is -3. So we'll assign this as x2, y2. So for finding the slope of line CD, I may need my formula. Y2 is -3 minus y1, which is 3, over x2 is -4 minus x1 is -2. So -3 minus 3 is equal to -9 over. So again, this is negative times negative becomes positive. So we have here -4 plus 2 will be equal to -2. I'm sorry, I made some mistake. Look at this one. It should not be -9, but it should be 6. Alright, so this should be -3 minus 3 is equal to -6. And we simplify this. -6 divided by 2, -2 is equal to +3. So the slope of CD is 3, the slope of AB is -1/3. They are not the same. So that means they are not parallel. Now we'll check for perpendicularity. How are we going to do that? We're going to multiply both the slopes. So -1/3 times 3, it's equal to negative 1. So the product of the slopes of these two lines is equal to negative 1. So therefore, the two lines are said to be perpendicular. Okay, perpendicular, sorry. Perpendicular. It means that AB is, or line AB is perpendicular to line CD. Alright, now I want you to try answering question 8 and 9 by following the same procedure. So for this, you cannot assume that these two lines are parallel because you can see it. Basically, you just need to find the slope first, then you can conclude that the lines are parallel or not. Okay, so I want you to try question 8 and 9. Now let's move on. The same topic, determine whether each pair of lines is parallel, perpendicular, or neither. For this type of question, let's take for example number 10. We have here the equation of line 1 and the equation of line 2. So we're just going to compare their slopes. So for line 1, it has a slope of 2, and for line 2 will have the slope of 2 as well. So they are the same. So what do you say if the slope are the same? They are said to be parallel. Okay, so let's try to look at this example. I have here the example number 30. So this is the equation of the first line and this is the equation of the second line. So as you can see, the slope of this is 6, all right? And then the slope of this is negative 1/3. Okay, so negative 1/3 and 6, definitely they are not the same. That means the lines are not parallel. What if we have to multiply them? Will they get a product of negative 1? Let's see. So if I'm going to multiply 6 times negative 1/3, this will give me negative 6/3, and that is equal to negative 2. So negative 2 is not perpendicular. So that means these two lines are neither parallel nor perpendicular. Okay, so I want you all to look at the same example, and I already shared with you the step-by-step solutions on how are you going to determine whether the pairs of lines are parallel, perpendicular, or neither. Please refer to that and try the rest of the questions. All right, next one we have here the next topic, which is finding the distance between parallel lines using perpendicular distance. So we're looking for the distance between two parallel lines. So before I'm going to discuss with you the solutions for each of the questions, let us try to look at this illustration right here. So basically, we have here two parallel lines in a coordinate plane. Okay, so we have here line 1 and line 2. And line 1 has an equation of y is equal to mx plus c1. C1 here is the y-intercept of the first line, and C2 is also a y-intercept but for the second line. Okay, and this is what we are trying to look for. How far is line 1 to line 2? So this is the line that we're looking for, and as you can see, they form the distance is perpendicular distance. Okay, now in our book, we have given series of steps, but in here, since we are taking the exam, we can use this simplified form of formula. So we have here to find the distance between two parallel lines, we will use D is equal to C2 minus C1. That means the y-intercept of the second line minus the y-intercept of the first line. Okay, over 1 plus m squared, where m here is the slope. Okay, since they are parallel, it means their slope will be the same. Okay, so taking this into account, let us apply it to some of the questions. So for number 9 and for number 10, as you can see here, uh, the y-intercept are given, okay? And then the x values are given, so the solutions are already given here. So try to figure out, these are very straightforward. And for number 11, let's try it by using this formula. Okay, so we have here y is equal to 3x, and then y is equal to 3x plus 10. So this is the first line, and as you can see, there is no slope here. So that means the slope, the y-intercept here is 0. So I can say C1 is having a y-intercept of 0. And then for line 2, the y-intercept is 10. So I can write C2 is equal to 10. Now, the slope are this. Okay, so our m here is equal to 3. Now, we are going to substitute the value. You can use your calculator to enter the value. So the distance will be the absolute value of C2, which is 10, minus the value of C1, which is 0. This is absolute value all over the square root of 1 plus your m, or the slope is 3 squared. Okay, so when you are going to enter it to your calculator, you will get these values. So the answer will be -10, or about 3.16 units in decimal. Okay, so let's try to take example 16. So for this example class, as you can see, it's not written in y-intercept form. How are we going to tackle this? So first, write the equation in y-intercept form, slope-intercept form, sorry. So we have here y is equal to 3x. 3x is going to be a transposed method, okay? So transfer it to the other side of the equation, becomes negative 3x plus 3. So this is the same as this equation. And the next equation would be y is equal to, this is transpose method, so positive 17 becomes negative, okay? Negative 3x minus 17. So we can find here, we can see that our C1 is equal to 3, and then our C2 is negative 17. Okay, negative 17. And then our m is both the same. This is negative 3. So we just need to substitute the value. C2 is negative 17. So plug it here, minus 3. Okay, all over the square root of 1 plus your slope, which is negative 3 squared. So when you enter this in your calculator, what you'll get is 2 square root of 10, or if you're getting the decimal, or if the decimal is given, it should be 6.32 units. Okay, so the rest of the examples follow this formula. This is the easiest way I could teach you this to save time. Alright, so I wanted to try number 12, 13, 14, and 15, and 17 for your practice.